Mic check, mic check. Am I audible? Welcome to another episode of the Bitcoin Developers YouTube channel. I am your host, Connor. It's been a little minute. I've got to apologize, but we're planning to be a lot more consistent this year. Can't leave you guys hanging on your Bitcoin builder journey. I'm curious, how is your Bitcoin builder journey going anyway? Is it going well? Are you in a good place when it comes to building on Bitcoin? Do you need a lot more help? Leave a comment in the comment section below on the type of videos and content you want to use. We've got such a large array of tools that we can use to build a wide array of different Bitcoin applications of all shapes and sizes. So do let us know the kind of content you want to see. Like I said, we are planning to be a lot more consistent this year. So look forward to seeing more streams and different types of content on this channel. But today we're going to revisit the Lightning Development Kit, or LDK, one of those tools that we can use to integrate Lightning and Lightning payments into different types of Bitcoin applications. We have had some rockstar devs join us in the past to help us understand how LDK works. We had Val and Jeff and Eric and others, and even to this day you guys still message me saying how you use those videos as a reference to understand LDK. So it's a good time and a nice time to try and do a bit of a refresher on that, and we'll have a lot more content going forward for you as well. So let's get into it. In this presentation, we're gonna talk a little bit about what developing on Lightning was like prior to LDK. We're going to talk about, why LDK is unique and the kind of area it fills in the ecosystem. We're going to talk about who's using LDK. There are a number of fantastic projects that are using LDK in all types of different environments. Then we're going to look under the hood. So we'll look at some of the technical architecture that underpins LDK. We'll go through some flows and show you some of the interfaces and some of the code that is typical for an LDK application and how that stitches together. And then we'll also talk about LDK Node, which is a simplified version of LDK that gives you some really sound defaults out of the box. And then we'll look at the kind of future roadmap and the things that we've got up and coming in the LDK open source project. So let's get into it. So let's talk about the importance of the Lightning Network. So we'll start by talking about Bitcoin on chain. Currently using Bitcoin when there's any kind of sufficiently high demand typically tends to be quite expensive, tends to be relatively slow as well. Because of the underlying blockchain technology, there's a limit to the amount of transactions that can happen at any given time. And so the underlying technology has scaling limitations, and the Lightning Network is an effort to help scale Bitcoin and make it possible essentially to send payments in a fast and cheap way. You'll hear the term layer 2 used in conjunction with the Lightning Network as well, because you have the Bitcoin base layer, which is layer 1, and then you have a layer on top of that, which is the Lightning Network, which we sometimes call layer 2. So typically you'll find Bitcoin will scale in layers over time, and that first iteration is what we've called the Lightning Network. So what was building on Lightning like prior to LDK? So our team, before deciding to work on LDK, we spoke to a lot of wallet developers about the challenges they faced when actually building on Lightning. And we learned that building on Lightning has a very rough experience, specifically if you want to build experience in the mobile context. And before LDK, if your team wanted to add Lightning functionality to a mobile app, you would have probably had to modify one of the existing Lightning implementations and make it suitable for mobile devices. I think we've seen this in the past with Breeze and some of the modifications they made with LND. Current implementations are out of the box node solutions, so they provide RPC and HTTP interfaces that are targeted for server environments and are not typically suited for mobile. So if you wanted to do things like turn an on-chain wallet into a unified wallet experience, or you wanted to source blockchain data from some type of third-party service, whether it be the Electrum protocol or Explorer or some other type of protocol, compact block filters, for example. If you wanted to do that for resource constrained devices, so in the mobile context, it can be pretty complex to make those modifications, and it's also very time consuming as well. So maintaining a Lightning implementation is complex. Maintenance costs are high, and that only increases over time as the code base age, and it requires you to have really a team with really strong in-depth knowledge of all of the ins and outs and the security requirements for building something like Lightning. So then along came LDK. So LDK is different in that it's not a daemon, but it's a full Lightning implementation that has been written as a SDK. So the core SDK is written in Rust, but we created LDK in multiple languages with an API first approach, and it's designed to run at the application layer. So you don't need to write an LN implementation from scratch, or you don't need to modify an existing one to get exposure to all of the Lightning functionality. So some of the projects that are using LDK include Cash App, which is a payment service in the US. We have Liquid, which is a LSP, a Lightning service provider, which we'll touch on a little bit later in this talk, which enables easier onboarding for users, especially on mobile. We have Albi Hub, which is a web extension that allows you to run a node in the cloud, as well as interface with a number of different applications, like Nostr applications, for example. We have BitKit, which is a mobile wallet. And they have Lightning enabled in their application as well. They also run an LSP service. We have Lightspark as well, and we also have Lexi. So let's talk about why people choose to build with LDK. So one of the reasons is its flexibility. So developers can customize on-chain wallets creation, blockchain syncing, key management, routing of payments, data storage, back-end logic. All of this kind of stuff can be done with LDK, and you can choose how to do those things. We'll go into more detail in that in a bit. And in terms of flexibility, it can run on mobile phones. It can run on different types of hardware devices, hardware security modules, for example. It can run in web browsers, and it can run in Lightning service providers as well, so more like infrastructure type of nodes. It's very performant. So the API is based on the Rust Lightning project, which offers clean interfaces, minimal system dependencies. LDK can perform on small footprint devices and scale in the cloud as well. And the cool thing about LDK is that we have language binding. So even though the core library is written in Rust, you don't actually have to know Rust to be able to use LDK. We support native APIs in Rust, in C, in Swift, Java, and Kotlin, and JavaScript as well. And you could build Lightning applications in your preferred programming language, essentially. And LDK is an open source project. So the aim is to build a sustainable open source project. So LDK maintainers spend a significant amount of time reviewing code, answering questions, writing documentation, and accepting sensible patches and pull requests. The development roadmap is something you can find on the website as well, and it's transparent for everyone to view. And corporate priorities never come first. So we have people funded through many organizations who are working on LDK towards a common goal. So let's dive a little bit into the technicals of how LDK works. So, like I said earlier, LDK isn't a daemon, but rather it's an SDK. So it's not like a single binary that's just designed to be kind of plug and play. The code is compiled and run directly in your application. So it's environment agnostic. So knows nothing really about things like your networking stack, the blockchain itself, how it's going to store data and persist that data. Users have optionality to provide these components, or we do ship with some defaults as well. So if we look at the top here, it shows like an indication of the necessity to monitor the Bitcoin blockchain and monitoring the chain for things like funding transactions when we're trying to open Lightning channels. And this can be done in a number of different ways. We can use the Electrum or Explorer protocol. We can use Bitcoin Core, or we could use a more privacy preserving protocol like compact block filters as well. And we provide an interface for you to decide how to broadcast transactions to the network as well. We don't know anything about the entropy you'll use for the keys. Rather, it's very generic in that we take a 32-byte seed to use as a BIP32 extended key, and then we can derive keys from that. And don't worry if you don't understand what that means, but it's something that will enable you to create a unified wallet, because the entropy used for LDK can be contained within that initial mnemonic. So that kind of 12 or 24 word phrase, the initial entropy can actually be contained inside there. And then the kind of experience that will lead to is users only having to have one private key to back up both their on-chain and Lightning funds. And then we also have the ability to persist data in asynchronous and synchronous modes for stuff like channel state. So it's very important to back up Lightning channel state periodically if you don't want to lose funds. Essentially, LDK state machine will not progress if these backups are not done in the right way and sufficiently. And then there are also some events. There are some events that users are required to handle throughout the life cycle of an LDK application. And these are notification based. So you'll get things like when your channels are closed, or when your funding transaction is ready to be broadcast to the network, these type of things, or when you've received the payment, or when you've sent a payment, or when a payment is ready to be claimed. All of these things are provided via events and notifications in LDK. So let's look at another bit of architecture here, just a very simple diagram here that outlines the peer management. So connecting to a peer is one of the first things you need to do when you're starting to build your own Lightning nodes. This is a network-based technology. This is handled in LDK with the peer manager, and that handles connecting to peers on the network and exchanges all of the necessary gossip messages between different peers. And it can communicate in a number of different ways. It can communicate to the Onion Messenger, which is responsible for sending and receiving Onion messages, which is necessary for stuff like Bolt 12 and Bolt 12 offers. It also speaks to the peer-to-peer gossip sync, and that's for handling updates from other peers, for the messages we want to forward to other peers, and announcing public channels, things of that nature. Users do need to implement their own networking stack by providing LDK the raw TCP IP information, and then LDK basically handles the rest for you. And we do ship with a default implementation as well. If you're using LDK, the channel manager is definitely going to be one of the core components that you'll need to be familiar with, and it's at the heart of a lot of what LDK does. It needs a way to persist the Lightning channel state to disk or to the local file system, or some kind of cloud service provider is possible as well. And we do provide a default KV store implementation or key value store implementation as well, that makes doing some of that a bit more trivial for you. And it also needs a way to broadcast transactions to the network. So some of these transactions include the funding transaction when you're trying to open a channel, and you need to monitor the chain to see when that transaction has been mined, and then the channel become operational. So you can listen for new blocks and monitor for unilateral closes, penalty and justice transactions, that type of thing. You can also implement flexible fee estimation. So you can choose where you source your fee information from, whether that be a Bitcoin core node. I know there's a lot of work being done to improve the accuracy of fees in Bitcoin core specifically, or you could use some other third-party service like mempool.space, for example. And the channel manager handles essentially a lot of the off-chain things as well. And the channel monitor that you see there is responsible for on-chain stuff. So the state of each channel must be updated as well at each block before progressing. Like I said before, it's important to periodically back up the Lightning state in order to reduce the risk of losing funds. So let's walk through a typical flow that you might see in a LDK application. So here we have an app that is running LDK, and we're connected to one of our peers, and this flow is outlining us being able to accept an inbound channel from one of our peers. So this kicks off by one of our peers sending us an open channel message over the wire, and this will instigate a open channel request in LDK, or an open channel request event. And in that event, we have the opportunity to call a function called accept inbound channel. And then when we call accept inbound channel, this sends a message to our peer to accept the channel. Then we do our peer sends us back the funding created and funding signed messages to indicate that we have a signed transaction ready to broadcast. And then we poll the blockchain in one of those various methods that we discussed earlier, whether it be Core or Explorer. And then when we have sufficient confirmations of that, our peer will send us a message over the wire saying, oh, cool, this channel's ready. And we'll send the subsequent channel ready message back to our peer. And at that point, our channel is operational. So from an LDK perspective, you essentially, as the person or as the peer accepting the inbound channel, you pretty much just have to do two things: handle the open channel request and accept inbound channel. This also is possible to. It's also possible to accept zero confirmation channels as well, but this is only to be really done in a trusted context where you trust your peer. So let's talk about payments as well. So in this diagram, we've got two applications that are running LDK. One of the applications is going to receive funds, and the other application is going to be the payer of the funds. So the receiver creates calls the create invoice method in LDK. It's been slightly updated actually to create invoice from channel manager, but the concept's still the same. And this returns an invoice, and this invoice you can send to your counterparty, the payer of the funds, usually out of bound, and the payer will call the pay invoice method, or that's slightly been updated as well to send payment. But again, the concept's the same, and you just pass in that invoice, and then that sets off this kind of HTLC dance. So once you call the send payment or pay invoice method, the receiver will get a pending HTLC forward event, and this essentially indicates that the channel manager should be called to process these pending HTLCs. So it will be called at some time in the future, and then we'll get a payment received event. The receiver will get a payment received event, or rather, it's been updated to be payment claimable now. And with the payment claimable event, this indicates that you've been offered a payment, and it needs to be claimed by calling something in the channel manager called claim funds. And then once the funds have been claimed, an event gets called payment claimed, and this sends a message over the wire to update fulfill HTLC to the payer of your application. And then there are two events that are initiated through that. One is payment sent, and one is payment path successful. So those events need to be handled on the payer side. So as you can see, it's this kind of back and forth of handling events, calling events, things being sent over the wire, and you having to respond to different things depending on where you are in the life cycle. Let's talk about some code snippets here. So let's just see some of the interfaces in action. Yeah. So we've got the fee estimator, for example, and this takes one function, get estimated sats per 1,000 weight. And this takes a confirmation target. And there are a number of different confirmation targets that are very kind of fine grained depending on what you're trying to do. So some of them include, one of them is called an urgent on-chain sweep. So that indicates, let's say we have some funds and they're available on-chain, and we need to spend them prior to some expiry time before our counterparty has the opportunity to take those funds. Or we have like the channel close minimum. So when you cooperatively close a channel with your peer, this is the minimum fee rate that we will accept, and it's recommended at least within a day or so worth of blocks. And then lastly, there's the output spending fee. So this is a fee rate you might want to use to claim on-chain funds, but there isn't any particular urgency to do so. So there are about maybe 6 or 7 more, or maybe 5 or 6 more confirmation targets as well that are available, and you can just look at the documentation to find those. But you do really have fine-grained control over that. This is a very simple interface. So this is the broadcaster interface. So this is you need to implement a function called broadcast transactions that takes a set of transactions, essentially takes a list of transactions that will hopefully be mined, and this only needs to handle the actual broadcasting of transactions. LDK will automatically rebroadcast any transactions that haven't been made into a block for some reason, or that haven't made it into a block for some reason. So cool. So that's some of the under the hood stuff, but it can be not trivial to stitch all of that together. It does take a little minute to get your head around it, and so we have identified that, and we've tried to create a more streamlined version of LDK, and that's called LDK No, and it essentially simplifies some of that stuff for non-custodial mobile applications. So it's kind of mobile first ready set of defaults that allow you to integrate all of that functionality using a number of methods that are predefined and have predefined defaults. So it comes packaged with these ready to go modules. The LDK full API has a very rich library and a over, at this point, maybe 400, 500 methods that you could call. So it's very dense, but LDK Node is a lot more streamlined. The number of methods has been reduced significantly, and you only have to really call a handful of those to get much of the same functionality. It also supports language bindings as well, so you can, like with the LDK proper or the full LDK API, you can write in Kotlin, in Swift, in Java, and Python. Most of the applications, the popular languages out there as well. So Lightning development is tough, but application services make it that little bit easier. So LDK builders can work with some commercial partners to self-host servers or do both. So you can have a combination of self-hosting some of the infrastructure as well as using commercial partners to lean on as well. Some of these include Liquid, which is an LSP, which is a Lightning service provider, which enables you to allows your users to pay for inbound liquidity and receive payments without already having channels open. Let There Be Lightning hosts a number of different application services as well. Everything from VSS, which is version storage system or service that enables you to back up your channel state in the cloud in a secure way. And then we have stuff like you have the ability to connect to their Explorer instances and Electrum instances as well. And Voltage is very, very similar in that way. So there are a whole host of infrastructure providers that you can plug into to leverage their infrastructure if you don't want to self-host, at least initially anyway. And then the roadmap. So let's talk about some of the things that we've got coming up. So we have asynchronous payments. So currently, if you want to be able to receive Lightning payments offline, it's a bit tricky. So ASIC payments make it possible for transactions to go through even when a receiver is offline. We also have splicing. currently we don't have the ability to resize Lightning channels without closing and reopening them. So splicing gives us the ability to do that. So we can resize Lightning channels without having to go on chain. And then there are a number of performance upgrades that we're doing. So being able to scale channels per node, nodes, scaling the ability on the number of nodes to be able to be run per server, and also the amount of data that we can store per channel update. And then we have the LSP evolution, the LSP specification. So we've been working on the Lightning liquidity crate and contributing to the LSP spec. So there are a number of different organizations contributing to that actually. So we have Async, we have Breeze, we have the LDK project as well. And this will enable wallets to have interoperability amongst different LSPs within the marketplace. So a lot of hopefully it will lead to a lot of choice for users and reduce the amount of vendor lock-in that could occur. And then some other notable things are we're working on an LDK server iteration that will be pre-packaged to provide sensible defaults for those who want to run LDK in a more server-based environment. We've got custom scripts as well for people who want to do kind of like different types of custom applications on top of LDK. And we've also got Taproot coming as well, so Taproot channels, which is a significant privacy improvement for Lightning as well. So that's it from me. Where can you find us? You can find us over at lightningdevkit.org. We're on Twitter at lightningdevkit. We're on Discord as well. You can find all of the good links over on the website. Go check out the GitHub, Lightning Dev Kit. We've got a number of different projects that you can contribute to over there. We'd love to hear from you. So yeah, thanks for listening. I look forward to hanging out with you guys again soon. Watch out for more videos coming your way, especially the live streams. We've got everything from BDK to LDK to PDK to more coming on the channel. So don't forget to like, comment and subscribe, and I'll see you in the next one. Peace.